Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's easy level puzzle. And take that easiness with a grain of salt because it's considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. Today's puzzle is SVS number 458, Divisible Neighbors by Richard. And here are the rules. Apply classic Sudoku rules, which means in every cell in the grid, place a single digit such that every row, column, and designated 9-cell region contains the digits 1 through 9 exactly once each. All cells containing a digit that is a divisor of the sum of all the digits orthogonally adjacent to it are shaded gray. That is a 4. So say we had a 4 here that had, well, that's not going to work. Say we had a 4 here, which has, well, that's not going to work either. Dang it. I'm trying to find a possible, okay, it's 4 here, which has a 3. Let's not do that there. A 3, a 2, a 7, and an 8 adjacent to it must be in a gray cell. Since 3 plus 7 and 2 and 8 equals 20 and can be divided by a 4. So, okay, what does it mean to be orthogonally adjacent? That just means they have to share an edge. So, if a digit can divide into the sum of the cells that it shares an edge with, if the digit in the gray cell can evenly divide into the sum of the cells that share an edge with it. Is that right? No, hold up. A digit in the gray cell can evenly divide into the sum of the digits that share an edge with the cell that the digit is in, if it's in a gray cell. I think that's the way I would put it. So, for example, 3 plus 2 plus 7 plus 8 adds up to 20. 4 divides evenly into it, right? There's no remainder. A 3 in the corner with 2 and 9 as its neighbors is, well, you can't have 3 there. Well, anyways, 2 and 9 as its neighbors is in a white cell, since 2 plus 9 equals 11, which cannot be divided evenly by 3. You have to have a remainder in that case. So any gray cells must be able to evenly divide into the sum of the digits that share an edge, must be able to divide evenly into the sum of the cells that share an edge with that digit, with that gray cell. And the cells with white cells cannot divide evenly. The digits that are in white cells cannot divide evenly into the sum of the digits that share an edge with it, or cells that share an edge with it. There's too many different variables here. I hope that was clear, right? So again, the 4, since it's in a gray cell, must be able to divide evenly into the sum of the cells that share an edge with it, right? So 2, 3, 7, 8 adds up to 20. 4 divided by 20 does not have a remainder, so therefore that is valid. And, for example, this 3 does not divide evenly into the sum of 2 and 9, which are the cells that share an edge with it. So it must be white. Anyways, those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay. We know this 8 evenly divides into the sum of its digits. So it must add up to 8, 16, 24, or 32. You could have 32 if it's 7979. So that is possible. 2 divides evenly into these two digits, which means this is an even sum. 2 does not divide evenly into these digits, which means this is an odd sum. Same with this. Um... Where is the 8 in row 2? It cannot be any of these, so it must be one of those two. That's interesting. So that means the 8 in box 1 must be evenly dividing into the sum of the digits it shares an edge with. Whereas 3 has to be one of these two. 2 has to be one of these two. 2 must be one of those two. 2 can't be here or here. So those are all the 2s. 3 cannot be here or here, but it's one of those 3. That's a lot. 5 has to be one of those 2. 5 cannot be here or here, so 5 has to be one of these 3. And then we have 8s. 8 cannot be here or here, so 8 has to be one of those 2. Okay. If 8 were here, how do we evenly divide into it? 8 divided could be evenly divided into 8, but that would force this to be... It cannot be, because that's 1, 4, and 5 at minimum, which adds up to 10. Oh, 1 always evenly divides into the sum. So every... Yeah, so that's where it is. So every row or column that only has one gray digit must have a 1. So this must be 1 because of the gray digit there. 1 always divides into the sum of its neighbors that share an edge with it. So this is 1. This has to be 1 here. Column 7 only has one gray cell, so that's 1. 1 is one of... row 7 only has one gray digit, so that's 1. Which means where's 1 in column 4? It cannot be here because of 1's in the boxes. Can't be here because it must be in a gray cell, so it must be there. Where is 1 in row 2? Cannot be here because 1's in the boxes, so this must be a 1-8 pair. Where is 1 in row 5? It has to be here. So this 1 means this has to be 2. That means this has to be 5. 1 cannot be here. Where's 1 in column 8? It can only be in a gray cell, so it's there. Where is 1 in row 8? Cannot be here, so it must be here, which eliminates 1 here, so that's 8, which makes that 1. So that means 8 can divide evenly into this sum. It has to be 16. Because it cannot be 8, because 1, 4, and 5 at minimum add up to 10, because you don't have 2 and 3 in the box. So this has to be 16, which means the other two digits must add up to 15, because it's minus 1, so this must be a 6-9 pair. 1, 2, 3, 4, 5, 6, 7, 8, 9. Where are the 2s? Remaining digits of box 1 are 5 cannot be either of these, so 5 has to be here, which makes this a 4-7 pair. Remaining digits of column 1 are 3, 4, 5, and 7. Obviously no 5 here, no 5 here, no 3 here. Because of 5 in the box, this 3, 4, 7 triplet eliminates 3, 4, 7 in the rest of the column, so this can't be 3, 4, 7. It's 5. Remaining digits in box 4 are 6, 8, and 9. Remaining digits in column 2 are 4 and 7. Remaining digits of column 3 are 6, 8, 9. No 8 here because of 8 in the row. 2, that means this is divisible by, this is an even sum, so this cannot be 4. This is 7, which makes this 4. 7 evenly divides into these 3-digit sum, so it has to be 14. 2 plus 3 plus 9 is 14, which makes this 6, which makes that 8. So this is satisfied. 1 is obvious. All the 1s are satisfied. The 8 is satisfied. That evenly divides into 16. 7 divides into 2, 3, 9, which is 14. So that's satisfied. This is never going to divide into evenly into this. It's either 9 or 12. So that's satisfied. 1, 4, 7, 8 is 20. 3 does not divide evenly into that. 2 cannot divide evenly into this, but we don't know what that is. 2 cannot divide evenly into this. 5. So does 164 is 11. 167 is 14, none of which are divisible by 5. 194 is 13, and 197 is 17, and none of those are divisible by 5. Okay. We have 4 here. So we have 3, 5, and 6 here. That is 14. 14 plus 6 would be 20, which is divisible by 4, so this cannot be 6. 14 plus 8 is 22, which is 4 is not divisible by, and 14 plus 9 is 23, which 4 is not divisible by. So we're done with that. 1, 4, and 7 adds up to 12. So this cannot be divisible by 3 here, because these are already divisible by 3, and if this is divisible by 3 also, the sum would be divisible by 3. So no 6 or 9. It has to be 2, 4, 7. And this is done. These are too many variables here. Remaining digits of row 7. We have 3, 7, 9. No 3 here because of 3 in the column. 3, 7, 9. 1, 4, and 8 add up to 13. 13 plus 3 is 16, which is not divisible by 6. 13 plus 7 is 20, which is not divisible by 6. 13 plus 9 is 22, which is not divisible by 6, so that's fine. So that's green. Remaining digits of row 8. We have 2, 4, 6, 7, 9. Obviously, none of these could be 2. We don't know what the rest are. Eight. So 3, 6, and 9. 3, 6, and 9 add up to 18. The only divisible one would be 8. Or sorry, it would be 8 times 3, which is 24. 24 minus 18 is 6, so this just can't be 6 here. So then that's done. Remaining digits in row 2. We have 2, 4, 6, 7, 9. No 2 here because of 2 in the column. Remaining digits of row 3. We have 3, 4, 5, 6, 7, 9. No 5 here because of 5 in the box. 5 has to be one of these two. 5 is one of these 3. 5 is one of these 3. 8 cannot be here. 8 is one of these 2. Okay. These two digits add up to 15. This cannot be 18. So that eliminates 3 here. But, okay, so remaining digits in row 9 are 3, 4, 5, 6, 8. No 8 here. This cannot be 5 here. No 8 here. 3 can't be here because of 3 in the column. So where's 3 in box 9? 3 has to be one of these two digits. Well, that eliminates 3 in the rest of the column. This is 13, which both 6 and 9 are not dividing into evenly. Again, this can't be 3 because 3, 7, and 8 add up to 18, which 9 does divide evenly into. Can't be, it could be 6. 6, 7, and 8 is 21, which 9 does not divide evenly into. Either this is 2 or this is 2. And if this is 2, this cannot be an even sum. But we have 1, 5, and 8, which is already 14, which is even. So if this is not 2, this cannot be an even digit. So cannot be 4 or 6. Okay. What else do we have? 3 can't be here. 3 has to be either here or here in column 8. Or box 3. If this is 2, this has to be 3. So this would be 7, 9 as a pair here. If this is 2, this becomes 7, 9, and this is 3. So then 6 is not dividing into 8 or 10, so it would have to be 4. Can this ever be 6? 6 would have to be the sum of 6 or 12, and you can never reach 12 there, so this can't be 6. So either this is 3, which makes this 1, 2, or this is 4, which makes this 1, 7. So this cannot be 9. If you had a 6 here, we have 14 already. That would force this to be 2, and 16 is not divisible. 6 does not divide into 16. So that could work. So if this was 4, though, that doesn't work, right? If this is 4, that forces this to be 2. And 1, 5, 8 is 14 plus 2 is 16, which is divisible by 4. So 4 cannot be there. So 4 in box 9 has to be one of these two digits, which eliminates 4 in the rest of the row. Nine is satisfied. Hmm. Can this ever be 7? The answer is no. If this is 7, that forces this to be 3, 4, which adds up to 7. But then this has to be divisible by 7, which it's not because it's 6, 8, or 9. So that doesn't work. What about... So 7's one of these two. If this is 4, that makes this 3 and 7, which is 10. 10 plus 6 is 16, which is divisible by 4. And then 8 and 9 can't be here. So 4 works if this is 6. If this is 3, that's 4 and 7 here. 4 and 7 add up to 11. 11 plus 6 is 17, which is not divisible by 3. 11 plus 9 is 20, which is not divisible by 3. And 11 plus 8 is 19, which is not divisible by 3. So 3 does not work here. 4 has to be here, which makes this 7. That's 3. This is again 10 plus 6 is 16, which means this cannot be 6. So 4 is satisfied here. This cannot add up to a multiple of 7. 4, 5, 8 is 17. 4, 5, 9 is 18, none of which are divisible by 7. 6. This is divided by... So 17 plus 6 is 23, which 6 is not divisible by. We know 5, 1, and 6 are here. That adds up to 12. So this must be an odd digit. It cannot be 2, 4, 6, or 8. Well, it couldn't anyways. So it's 3, 5, 7, or 9. So then this is done. 3. Hold up. Is this... If this is... So if this is 2, this is 7. And that's 4. But this must be 4, 3. 4, 3, and 2 add up to 9, which 7 is not divisible by. So this cannot be 7. This must be 2. So we have 2 here. This must be 3 then. This cannot be 3 in the rest of the box. Therefore, these are both odd. This must be even and is 6, which makes this 4 here. That eliminates 6 from the rest of the row here. No 3 here. So this is 5, 6, or 8. Where is the 3 then in row 7? It has to be here. So this is 3. 2 has an even digit here, and this is an even sum, so that therefore that sum's going to be all even. 3 is satisfied because 1 and 2 is 3, which that's divisible by. 1, 2, 5, and 8 add up to 16, which 6 is not divisible by, so that's satisfied. These are odd. We don't have any more information. 8 has 16 around it, and then 6 here. So no 6 here. No 2 here. Remaining digits in column 9 are 4, 6, 7, 9. Remaining digits in column 8 are 2, 3, 4, 7, 9. Obviously no 3 here. If the sum of these right now is 16 plus 6, which is 22. If you have 2 here, that would be 24, which is divisible by 8, so this cannot be 2. This can't be 7 because of 7 in the row. And so this is satisfied now. This adds up to 15, which 7 and 9 both do not divide evenly into. We have 1, 4, not 1, 4, 7, which is 12, 1, 4, 9, which is 14, 1, 9, 7, which is 17, and 1, 9, 9, which is 19, none of which 5 divides evenly into. This is 6. 6 plus 6 would add up to 12, which 4 does divide evenly into, so this cannot be 6. And 8, 1, 5, 5 is 11, which 4 does not divide evenly into. 1, 5, 8 is 14, which 4 does not divide evenly into, so that's satisfied. Three eliminates 3 from being here. What is the sum of these digits? 1, 6, 7, and 4. 1, 6, 7 is 14, plus 4 is 18, which 9 does divide into, so this cannot be 9. It's 8, which makes this 9. So then this is satisfied. 3, 2, 5, and 6. I guess we could have done that way too. That's 16, which 9 does not divide evenly into, but 8 would. 2, 3, and 8 adds up to 13, neither of which 6 or 9 divide evenly into. We have 9, 4, which is 13, and 6 is 19, plus 9 is 22, neither of which 3 divides evenly into. So these are even. 1, 3, 5 is 9, so neither of these divide evenly into that. 2, 8, 3, 5 is 18, which none of these divide evenly into. Okay. Hmm. Remaining digits of row 6. We have 2, 4, 6, and 9. No 2 here because of 2 in the column. Okay, this is interesting. This is kind of interesting. Okay. Can this ever be a 9 here? That would mean 5. So 5 and 8 is 13. That would mean this has to be 18, but that would require 5 here. So 9 cannot be here. 7. 13 would mean 14 or 21, but that would be 1 or 8 here, which is not possible. So this can't be 7. 6. 13 would mean 18 here, which is 5, which is not going to work. So this can't be 6 here. This is 4 then. That eliminates 4 in the rest of the row, box, and column. No 4 here. No 4 here. So 8, 5 is 13. Plus 3 is 16. 13 plus... Hold up. 7 is 20. So it's 7 here, which makes this 9, which makes that 6. So that's now good. That eliminates 7 from the rest of the box. And we already did the column. That means the row. This can't be 7. This is 4, which makes this 7. 1, 4, 9 is 14, so this cannot be 6 here because that would be 20, which is divisible by 2. So this is 9, that's 6. So this is satisfied now. No 4 here, no 9 here, so this is 3. which means this cannot be 3 here. No 3 or 9 here, so it's 5 and 6 as a pair, which eliminates 5 and 6 in the rest of the box. So this can't be 6. This is 2, 7, 9 as a triplet, which eliminates 2, 7, 9 in the rest of the row. No 2 or 9 here. It's 6. That leaves this as 2 or 9. And remaining digits of row 1 are 3 and 4. Okay. We have 5 and 6 both divisible here. Or dividing into the sum. This has a sum of 2 already. If this is 6, you'd have 2 plus 5 is 7. 7 plus 7 is 14, which is not divisible by 6. 7 plus 9 is 16, which is not divisible by 6. So this can't be 6. This is 5 and 6. This is 8. 8 plus 7 is 15, which is divisible by 5, and 9 doesn't work here. So 7 eliminates 7 here, so that's 2. This is 9. So 5 is satisfied. 9 must be dividing into this. So that's 2, 6, 7. So that's 9 here. This must be 6 and 3 then to add up to 9. So that's satisfied there. That makes this 4. 1, 9, and 4 add up to 14, which 3 is not divisible by. 1, 8, 3, 9. These are 3 odds and an even, which gives you an odd sum, so 2 is not divisible by that. We have 12 here, which means this must be 16 as a sum, so this must be a 4. Because 24 is too large. So then this is satisfied now. 6. We have 5, 8, and 9. Which is 22. 4 and 9, eliminate 4 and 9 here. So that's 2 and 7. 22 plus 2 is 24. Plus 8 is 30. And those are both divisible by 6. So this is done. That moves this as 2, 7, or 8. 4. If this is 3, 7, 2, that would be 12, which is divisible by 4. So this cannot be 2. This is 9, which makes that 2. So this is satisfied. 2 and 8, 4 is 8 is not divisible by, does not divide into 6. 5, 8, and 9 is 22, which 2 is divisible by dividing into. 2, 4, 6 is 12. That satisfies that. 2, 4, 3, and 6 adds up to 15, which 5 does divide evenly into. 9, 9 and 1 is 10, plus 5 and 7 is 12, so that's 22. 6 does not divide evenly into that. 4 and 6 is 10, 5 and 9 is 14. 14 plus 10 is 24, which 7 does not divide evenly into. Okay. 7. This is 4, 6, and 3. 13. 7 does not divide into 13. 3. We have 1, 5, 7, which is 13. 13 plus 2 would be 15, which 3 would divide evenly into. So this cannot be 2. It's 7. Which means this can't be 2 or 7. So it's 4 or 9 as a pair. So now this is done. 6, 1, 7, and 7 is 15. 6 does not divide evenly into that. 4 eliminates 4 here, so this is 9, which makes this 4. 9 eliminates 9 here, so it's 7. So again, 16 plus 10 is 26, which 8 does not divide evenly into. 3, 9 is 12, plus 8 is 20, plus 5 is 25, which 4 does not divide evenly into. This is 2, 8 as a pair. This 2 eliminates 2 here, so that's 8, which makes this 2, which makes this 8. 1, 1, 7, 8. That's 17, which 2 does not divide evenly into. 2 cannot be here, so 2, where's 2? This 4 eliminates 4 in the rest of the row, so where's 2 in row 6? It's here. 9 eliminates 9 here. 7 has 2, 3, 6, which is 11 plus 9 is 20, so 7 does not divide evenly into that. 1, 7, 8, 4 is 20, which 9 does not divide evenly into. Nine eliminates 9 here. 8 and 6 eliminate 8 and 6 here, so this is 5, which makes this 8, which makes that 6. Again, 21. 9 does not divide evenly into that. This cannot be 5. This can't be 4. So that makes this 7, which makes that 4. Which means this can't be 4 here, no 4 here. 6 eliminates 6 here, so that's 9 and 6. Which makes this 7 and 9. This has to be 5, and let's go through these to make sure. 4, 4, 2, 9 is 11 plus 8, which is 19, which 5 does not divide evenly into. 8, 8, which 4 divides evenly into, but 10, that 4 does not divide evenly into that. So that satisfies that. 6, 4, 1, 7 is 18. 8 does not divide evenly into that. 2, 4, 7, 9, 16. Plus 4 is 20. Plus 2 is 22. 5 does not divide evenly into that. 7. That's really the one that's probably concerning. 7 has 11 here. Plus 6 is 17. Plus 4 is 21, which does satisfy that. 1, 7, 6, 9. That's 3 divides evenly into 9 and 6, but does not divide evenly into 8, so that satisfies that. 1, 2, 3, 5 is 11. 9 does not divide evenly into that. 1, 6, 9, 7. So 1, 6, 9 is 16, plus 7 is 23, which 2 does not divide evenly into. How about this one? 1, 9, 10, 23 again, which 2 does not divide evenly into. 5, 7, 9, which is 21, which 6 does not divide evenly into. 6, 4, 8, 18, which 5 does not divide evenly into. 1, 7, 5, 9, that's 22. 4 does not divide evenly into that. 4, 5, 9 is 18. 8 doesn't divide evenly into that. 2, 4, 5, 8, 19, which 9 does not divide evenly into. 9 and 7, 16. Plus 10 is 26. 5 does not divide evenly into that. 2, 3, 8, 5, 18, which 7 does not divide evenly into. 4, 6, 10, plus 15 is 25. 3 does not divide evenly into that. 3, 3, 2, 2, 10, which 6 does not divide evenly into. 2, 8, 3, 5, which is 18. 17 does not divide evenly into that. 2, 3, 3, 9, which is 8 plus 9, which is 17. 8 does not divide evenly into that. And 1, 7, 6, 8, which is 21 plus 1 is 22, which 3 does not divide evenly into. Yeah, fairly straightforward about these. Lots of math. Lots of math. Yeah, just pretty straightforward. I'm not sure what else I could say about this puzzle. But I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.